Hi, Assalamualaikum and very good day to all of you. My name is Nursah'aidah Md Sahak and I'm from University Putra Malaysia. Today I would like to present to you my paper with the title of Pervious Materials for Flood Mitigation Process in Kuala Lumpur, a review. Okay, without any further delay, I will briefly introduce about the topic. Urbanization of the landscape has a significant negative impact on the quantity and also quality of the water runoff entering our lakes and streams. These impervious surfaces can transport many pollutants deposited in urban areas such as nutrients, sediment, pesticide and also fluoride. Efficient collection and routing of stormwater runoff in urban areas are essential to minimize the localized flooding and also provide efficient drainage to the properties. Pervious or permeable pavement are an alternative PMP, which is best management practices, to impermeable pavement because they can encourage infiltration or filtration of stormwater runoff while still providing structural capacity. Pervious surfaces can be hardscape such as pavement and also softscape such as buffer garden. Okay, this can be discussed in the next subtopic. The first pervious surfaces that will be discussed is permeable pavement. Okay, this permeable pavement is the most common system. It has full infiltration that will direct the water through the base or subbase reservoir and infiltrate it into the soil subgrade. The partial infiltration system rely on drainage of the base or subbase into the subgrade soil and drainage pipes to direct the excess water to a sewer or a stream. Permeable pavement system are typically designed for stormwater storage, treatment and also potential infiltration into the subsurface soil. And the critical factors that affect the selection and design of the system are specific use for the pavement and adjacent area. No infiltration system are required when the soil has very low permeability and low strength. It also needs restrict groundwater recharge into soil with contamination. As you can see here in the figure 1, this is the generic permeable pavement cross section. It has the layer, the subbase and also the subgrade soil. Next, we move to the types of permeable pavement. Actually, there are a variety of types of the pavement, but here I will present 4 types of the pavement. The first one is the porous asphalt. Typically, porous asphalt consists of conventional hot mix asphalt or warm mix asphalts with significantly reduced fine, resulting in an open graded mixture that allows water to pass through an interconnected workspaces. The layer depth is based on structural load, stormwater requirement, and also the frost depth requirement. The figure shows the typical porous asphalt cross-section. There are 3 layers on top of the soil subgrade. The first layer is porous asphalt, and the second layer is the permeable base, and the third layer is the subbase reservoir. The next type of permeable pavement is the pervious concrete. This concrete overall thickness is determined based on hydrologic design, vehicle loading, and frost depth consideration. A minimum thickness of 12 inch in freeze-thaw climates is typical. The figure shows the typical section of pervious concrete pavement. There are 3 to 4 layers on top of soil subgrade. The first one is pervious concrete, the second one is the permeable base, and the third one is the subbase reservoir. And it may require a non-woven geotextile fabric. The third one is permeable interlocking concrete pavement, or in short we call PICP. This PICP consists of manufactured concrete units that form permeable boards and joints when assembled into a laying pattern. It typically includes a small size aggregate bedding layer below the pavement surface and on top of the choke stone layer to ensure a level surface for the pavers or the grids. Okay, the figure shows the typical PICP cross-section. There are few layers on top of the soil subgrades. The first one is the concrete curb or the pavers. The second one is the paver joint material. The third one is the bedding course. The fourth one is the choker course. And the last layer on top of the soil subgrade is the subbase reservoir. The last types of the permeable pavement here is the grade pavement system. This pavement consists of concrete or plastic units with large surface openings filled with a permeable joint material, typically small aggregates, sand or topsoil and grass. The plastic grade units are placed directly over an open graded aggregate base or over a thin bedding sand layer on a dense graded base, while the concrete grade units are typically placed over a thin sand bedding layer and dense graded aggregate layer. Geotextile may be used in the design to provide separation of the aggregate base from the soil subgrade. Okay, this figure shows the typical grid paving unit cross-section. There are either concrete or plastic grid units on the top and sand bedding course, and also the subbase reservoir. Okay, this is the advantages and disadvantages of the hardscape of pervious surfaces. There are few advantages which managing the stormwater runoff can reduce the size of storm sewer and also reduce the risk of flooding, reduce contamination in waterways by filtration the water runoff, recharge groundwater supply, cool down the temperature of urban water runoff. There can be reduced stress and impact of the stream or lake environment, reduce heat island effect, help re-establish a more natural hydrologic balance, and reduce groundwater volume by trapping and slowly releasing precipitation into the ground. And also it reduces the need of a regional BMP, such as a wet detention pond, which save money and effort. While the disadvantages of this hardscape is it can be limited use in conjunction with heavy vertical loads. It has potential lack of experience with design and construction, and also it has potential lack of experience with maintenance that can lead to poor performance. Can be possible groundwater contamination from the fluid spills, and also potential higher initial construction costs. Okay, next we move to subscape of pervious surfaces, which is buffer garden. Buffer garden is a perennial garden that is built between homes and waterways and is an important way to reduce the flow of excess nutrients and also the pollutants that stormwater runoff can carry into storm drains. The plants can help to slow the runoff and allow it to soak into the ground before it flows into the storm drains. Using plants to buffer runoff goes a long way to protect our local waterways. Okay, this figure shows the typical buffer garden cross-section. There are two types of buffer garden. The first one is the rain garden and the second one is the bioswale. The first one is a depressed area in the landscape that collects rainwater from a roof, driveway or street and allow it to soak into the ground. Planted with grasses and flowering perennials, rain garden can also help filter out pollutants in runoff and provide food and shelter for butterflies, songbirds and other wildlife. The typical rain garden consists of soil, mulch, ponding water and also the plant. The ponding water usually will increase or decrease, depends on the situation. The second types of buffer garden is bioswale. Bioswale are stormwater runoff conveyance systems that provide an alternative to storm sewer. The bioswale can absorb low flows or carry runoff from heavy rains to storm sewer inlets or directly to surface waters. Bioswale improve water quality by infiltrating the first flush of stormwater runoff and filtering the large storm flows they convey. The figure shows the typical bioswale cross-section is look much alike with rain garden but differ in the well-drained soil and the small stones in the layer. Okay, next, the advantages and disadvantages of the subscape of pervious based surfaces. Okay, it can improve water quality by filtering out nutrients from rainwater runoff before it reaches stormwater sewer and waterways. It also has a unique landscaping features that relatively low maintenance. It has tendency to be pest and disease free relative to conventional landscape. Also can be a habitat for birds and butterfly, prevent rainwater runoff from entering the stormwater sewer system, protecting communities from drainage problem and flooding, increasing groundwater flow, creating natural wildlife habitats, and improving the way a landscape functions with effective green infrastructure. It has one disadvantage: it can accumulate standing water if it is not built correctly, and also it can increase the erosion. As a conclusion, although buffer garden has few to none disadvantages and more natural to environment, this garden cannot be considered as an ideal design for urban area due to lack of available soil. Rain garden is not recommended to plant over a static system, close to foundation or where the seasonal high water table is within 24 inches of the soil surface, while bioswale are not recommended in location with low infiltration rates because standing water, localized flooding and other issues can cause problems within the street and sidewalk in an urban environment. Therefore, permeable pavement is the ideal design for urban area with low availability of soil. Permeable pavement offer a number of environmental, operational and economic benefits. The most critical limitation is the lack of expertise in permeable pavement technology. And I hope that we can hire or find many expertise in this technology sooner or later. Okay, that's all from me. Thank you very much.